first place I really want to start is a set of physical laws and really understanding sustainability versus green. And from my perspective, I worked for a major engineering firm in the country developing large industrial, commercial, institutional projects. And I would say this graphic that's up right now, the idea of physical laws, absolute terms, informing what sustainable design ought to be and then what sustainable buildings really ought to be is not, it's understood, but it's not placed in practice very much at all. The idea would be very much that we could get to some sort of target based on this, that right there in the center ought to be what all these projects are aiming at. And what we really have right now with things like the USGBC's LEED program is a set of relative ideas. It's all relative to industry standards or products that are in the marketplace currently that are informing what I call green design, or something that's substantially less than sustainable design, resulting in green buildings and resulting in sort of a target that's substantially sort of off the mark. So you have this set of relative terms that are defined by the industry, defined by political will, defined by the architectural and engineering community by sort of what's comfortable to manage a conversation around with their clients, versus absolute terms that are really set by the physical world and the laws of the environment. This is a good example of a project that really strove to absolute targets. This is the Aldo Leopold Legacy Center by Kubala Washotko Architects. This is in Wisconsin here. You all could go visit it in a short ride. Great project. The problem I have with projects like this is not that they're not wonderful performers. It's not that they're not extremely well designed. It's that this is an 11,000 square foot nature center. It doesn't have a very high occupancy. It doesn't have a whole lot of things that it as a building is trying to accomplish or produce. And most of the world is trying to build things like this. This is the King Abdullah University of Science and Technology in Saudi Arabia. This is what my firm spent 3 years trying to help design and build simultaneously. It's 5 million square feet. That's all PV panels on the top. Here's a different picture of it. That's being constructed. That's the Red Sea right there. There's all sorts of renewable energy opportunities here. We put 9 megawatts of solar on this thing. We invested heavily. The only thing that constricted this project was the speed by which we could make decisions and design interesting technology into these. I mean, we could afford anything. This is the king's money, quite literally. And we couldn't, there wasn't enough technology to get the building to a point that was low enough to consume a small enough amount of energy to supply the balance with renewable power. And that's I think the critical concern from my perspective, is this concept of intensity and availability of renewable energy, the perceived economics for the average consumer, not the king of Saudi Arabia, and this idea of preference and norms. And I know other speakers will talk about the preference and norms and some of the sort of things we as humans sort of hold up as constructs. But I just want to spend a couple minutes on this. So the intensity availability thing, the engineering and architectural community have been working very, very hard to put tools in place for all designers to understand these issues very well. We know how much wind is coming from which direction at what hour of the day in which month of the year. That's not a problem. We know how much solar energy is falling on any square foot of any surface. There's computer programs for all of that you can make a very visual graph over every surface on a three-dimensional model. We can understand all of that very clearly. That's not the issue. We can understand the economics very well. This is a carbon abatement diagram you see on the far left. The concepts that save money per ton of carbon dioxide they abate. The concepts on the far right are things that cost money per ton of carbon dioxide to implement. All of the renewable energy measures are those skinny little bars far on the right side of the diagram, unfortunately. The good news is all the conservation opportunities are the things on the left side. They're all extremely fiscally efficient things to do that everybody should be doing, except people just don't understand them very well. They don't know where they are. They don't know how to get at them. They don't have the right funding to put them in place. The opportunities in conservation are, sorry to the renewable energy world, at least as great, if not more important than the renewable energy side. And we need to work hard to get there. This is, a couple speakers have talked about the price of natural gas. This is the current state of the world on natural gas, that little line that where the gray ends there on the far right, a little bit over $2 a therm. This is currently what a lot of people are making decisions around. Like, this is always going to be the case. This is a historic low for the prices of natural gas. This will not always be the case. So don't make long-term decisions based on this. That the rest of the colors on there are all sorts of different future trends for how this is going to change. And certainly it will go up. It has to go up. And as major players in the natural gas world make a lot of investments here, they're going to drive the smaller players to more complicated decisions and less optimized decisions around this. So again, making conservation very important. Then there's the whole set of preferences and norms and the things that we as human beings want more so than need, particularly in the United States. This is, you know, a set of ideas there around energy rates and schedules of buildings and comfort criteria. Particularly comfort criteria, this is not for anywhere in Wisconsin, but this is an indication of hot and cold and humidity. And as part of my new firm, I now work from home in the comfort of my living room, basically, and my wife won't let me turn on the air conditioner, so, you know, hats off to her. But it's taken me a while. I need to lose a little weight and, you know, get used to working in that new world. I mean, the last 12 years, I've gone to an office building that's 70 degrees every day I show up there, regardless of what time of the year it is. And about 3 months into the deal, I'm feeling fine about it. I don't want to turn on the air conditioning anymore either. But every one of the major clients that I've designed for in the last 12 years says, we got to have these very tight criteria on how our buildings work. And we're starting to explain and understand the nuanced conversation to get people away from that decision point, but we're not there yet, and it's certainly a very complicated conversation. 2 more slides. This is the Aldo Leopold Legacy Center was a AIA Committee on the Environment Top 10 award winner. That Kaus project, that 5 million square foot project in Saudi Arabia, that was an award winner too. So that's the spectrum around what the American Institute of Architects thinks is a very or extremely sustainable project in the world. This is the rest of those projects that have been awarded in the last 5 years. This is the square footage is on the far right of this graph. The energy use intensity is on the left side. So the energy use intensity is all over the map. I mean, these are not net zero energy buildings by any means. I didn't put Kaust on there because it made all the bars look ridiculously small. 5 million square feet made everything look, you know, tiny. But the red is the renewable energy that's provided to any of those buildings. I mean, we really have to get that conservation and energy efficiency in line with how much energy can be supplied. It's all about understanding what's there and then trying to do energy balance and energy budget for the development of the project. The last thing I'll show is this graphic. This is kind of how we're taking the set of tools. DOE2 is a modeling program for complicated buildings. Energy Plus is getting a long way for how to model the performance of buildings over time. And we can now understand by space and by end use of utility how much energy is being consumed in sort of a business as usual world, as well as the design case, and then how much renewable energy there is available on various surfaces or through wind technology or other technologies to get to trying to balance out that concept with how much renewable and get to that net zero place. I think the tools are there. It's the physical laws and the willpower that we have to work on so hard, and that's why, you know, all of you are important to help have that conversation, and why the other speakers today will, you know, help us move that forward as well. So thank you.